With just kind of rehashing what we did yesterday, dealing with the trigonometric functions, remembering that because we're in the unit circle, our radius is 1, right? So if we were to kind of superimpose a right triangle in there, maybe a special right triangle, and we try to deal with the hypotenuse being 1, we're going to be able to find the values of the two legs of the right triangle. And essentially, those two legs are going to provide you your rectangular coordinates for the ordered pairs on the unit circle. Okay, and what I mean by that is if I take, let's just say, this triangle right there, correct? 30, 60, 90 triangle. 30-degree angle here. Let me change the font so you can see it maybe a little bit better. All right. So we got 30-degree angle down there. Putting this orange triangle in, then with the radius being 1, we're able to determine that this y value would be 1/2. This leg of the right triangle would be 1/2, and this leg would be √3/2. And you see that those end up being the x and y coordinates, because if I wanted to travel from 0, 0, remember what's going on here, guys. We are, actually, let me do this. Let me put the grid in here. We're inside the coordinate plane, right? Okay, so how we travel from point to point is still the same as always. Start at 0, 0, and I want to get to this green point. I'm going to have to travel a horizontal distance, which ends up being the same as that leg of that right triangle. And then I got to travel a vertical distance, okay? And we find out that those two things, the √3/2 and the 1/2, are those two distances respectively. Does that make sense, everybody? Okay. Now, if this distance here is 1/2 and this distance here is √3/2, and my hypotenuse is 1, okay? And I asked you guys, what is maybe the sine? Let's just deal with, I'm going to write it as pi over 6. The sine of pi over 6, okay? Which would be either that angle, or if we want to talk about that arc measurement, okay, we've been calling that t, right? If I'm interested in evaluating the sine at that value, then all I have to do is realize that that is opposite over hypotenuse, right? Well, the opposite side is this vertical distance. My hypotenuse is 1. So the sine then is just whatever that vertical distance was, right? Does that make sense, everybody? And that vertical distance is just that y value right there. Okay? So we would say sine of pi over 6 is 1/2. If you evaluate that on your calculator, make sure you're in radians, it will spit back 0.5 to you. Okay? For the same logic then, cosine is adjacent divided by hypotenuse, but hypotenuse is 1. So cosine in the unit circle is just the adjacent distance, which we call x, right? So that's where we're getting these relationships that sine of t is equal to y, cosine of t is equal to x. Okay? Whenever we're on the unit circle, no matter what point we're interested with this thing, if I ask you what is the the cosine of 3 pi over 4, so now we're looking at this point right here, from that ordered pair, the cosine is the x coordinate. So cosine is negative √2/2. Okay? And if you type that in, if I were to go to cosine of it was 3 pi over 4. If I'm evaluating that, you see that does give me negative. Okay, that's a negative there. And then 0.707 is radical 2/2. Okay? Is that all right with everybody? Okay. Those of you that are using your TIA 384, that's fine. Okay. I'm going to jump back and forth between all three of these programs, Desmos, the TIA 384, and GeoGebra. Okay. But I do think, obviously, for those of you that have taken the ACT, who took the ACT last week, 2 weeks ago? Okay. There's some sine, cosine tangent stuff on that, right? Towards the end. Yeah. Oh, okay. Okay. Yeah. So the rescheduled one was Saturday. At the end of those, always on the ACT, that they do some of these trigonometry questions, and it might deal with cotangent or secant or cosecant, and you can't use those buttons on your calculator, right? You don't have those buttons. You have to use one over either tangent, cosine, or sine, respectively. I like Desmos because if I'm interested in what the secant is, I can just type in secant of pi over 4, and it gives me its radical too. Okay, does that kind of make sense? So that's kind of why maybe I'll jump around from program to program. But that's ultimately what we're looking for, guys, is can you recognize that if they're asking me for the sine of 7 pi over 6, so now I'm right here on that, okay? So the angle that I've traced out, okay, following that green arc, okay, or I guess green ray, 7 pi over 6 would be there. So now the t value that we've been talking about all week would have been that thing right there, right? Okay, and that's that t value is 7 pi over 6. But if you guys want to look at that as being theta, it is also 7 pi over 6, right? So it doesn't really matter the way you view this. Do you want to evaluate the angle, or do you want to evaluate the arc length because they're the same? It's fine. But if I wanted the cosine of it, the cosine of 7 pi over 6 is that number right there. The sine of 7 pi over 6, that number right there. Okay? Is that doable? If you remember what we did in Chapter 5, and we didn't do a whole lot of this for this reason. In Chapter 5, there was a chart. Oh, that's not what I wanted. All right, there was a chart that said we're going to look at theta and then be interested in the sine for it, the cosine of it, the tangent, the cotangent, the secant, and the cosecant. Okay, and then it started giving me things like, okay, 0 degrees. This thing's dumb. 0 degrees, 30 degrees, 45 degrees, 60 degrees, and then we had, okay, well, that's 0, that's 1. This would be the sine of 30 is 1/2. This would be square root of 3 over 2. And we fill in that entire chart. You guys remember kind of vaguely seeing that? Okay. That'd be a pain in the butt to remember, wouldn't it? Because now you have a bunch of numbers. I mean, there's some pattern to it, but you have a bunch of numbers that you got to remember or memorize the location of in that chart so that you can answer questions like, what is the cosecant of 7 or 60 degrees or something like that. Okay. The unit circle, I think, is a much more organized format of that. Okay. And it also provides maybe a visual for you that on that table, if you forgot a value in that table, it might be really hard for you to kind of do other work that might allow you to generate that value. Does that make sense? Here, if I forget a value, if I forget an ordered pair, can I just implant some special right triangles and go through a little work with hypotenuse of 1 and develop those ordered pairs? Does that make sense? Okay, so this is a much more preferred method of being able to learn these critical values, these critical ordered pairs for the sine, cosine functions, and then the tangent, cotangent, secant, cosecant that are associated with them. Is everybody kind of on the same page with me on this? Now, what's nice, and we've talked about this the last couple days, you really only need to learn that ordered pair, that one, and that one, okay? Because they're all replicated over here using symmetry in the second quadrant, third quadrant, and fourth quadrants, okay? So today is going to be kind of a culmination eventually of all the things we've talked about in the last 4 or 5 days so that we can evaluate things like, what is the sine of 10 pi over 3, okay? And we'll go through the process of trying to quickly evaluate that without a calculator, okay? So these are the relationships that we come up with, okay? If we've got a point on the unit circle, the sine is the y value, the cosine is the x value. The tangent then is y divided by x, okay? Y divided by x. Now, if I look at the tangent, y divided by x, what would be my x value for a point right there? What would be the ordered pair for that point right there? 0, 1, okay? So if I have this point 0, 1, and I ask you what is the tangent, okay? Now that arc that would have been traced out by P would have been 1.58 radians, which is pi over 2 radians. Is that right? Okay. So tangent of pi over 2. If I ask that, all we've got to do is we take y divided by x. Well, y divided by x in this case would be 1 divided by 0. What's the issue with that? Can't do it. It's undefined. And that's what feedback you're getting here when I take on my calculator tangent of pi over 2. It's undefined. Okay. Where else on the unit circle would you have an x value of 0? Yeah, 3 pi over 2. Okay. So down there you would have undefined. So tangent is undefined. And we'll write this again later. Undefined at pi over 2, at 3 pi over 2. What about making one complete revolution and then there again? Would that be undefined again there? So from here, what should I add? How many radians should I add to get that point to move there? What'd you say? 2 pi over 2, which would be better said as just pi, right? Okay. So take 3 pi over 2, add pi to it. So we get 5 pi over 2, right? Add pi to that, I get another place where I have division by 0, correct? So does it make sense that if I take pi over 2 and then add to it multiples of pi, where n is an integer, okay, and that's going to allow me to get those multiples, okay, be 1 pi, 2 pi, 3 pi, 4 pi, and that's going to keep getting back to oscillate back and forth between those two spots. Does that make sense, everybody? So if you're ever asked one of those things, if you realize that your terminal point is, on the positive y-axis or the negative y-axis on the unit circle for tangent, it's undefined because you're dividing by 0. Okay. Now I don't know if I said it, but why is it y divided by x? Well, haven't we talked that tangent is equal to sine divided by cosine? And isn't this in a unit circle? Haven't we defined that sine is just your y value of your ordered pair, and tangent is just your x value? Sorry, not cosine is just your x value. Does that make sense? Okay, so using these two things here, and the fact that we know tangent is sine divided by cosine, that's where we get that thing. Okay, cosecant is the reciprocal of sine, so it's 1 over y. Secant is a reciprocal of cosine, so it's 1 over x. And then obviously cotangent is the reciprocal of tangent, so it's x over y. All of these that have quotients, they all have division. You have places where you cannot divide by 0. Okay, so these two are going to have the same issues, right? It's because x cannot be 0 in those two. So at pi over 2 and 3 pi over 2, we have undefined values for the tangent and the secant. These two, the cosecant and the cotangent, they both have y as a denominator. So that's where y cannot be 0. On the unit circle, where is y 0? At what points? Yeah, okay. There at either 0 or 2 pi, however you want to phrase that. And then over here at pi, right? Those ordered pairs would be both, either 1, 0 or negative 1, 0. So there we have issues at essentially multiples of pi. Okay. So those are some things to think about as you're asked to evaluate your trig functions. Okay. So this is what we're looking for. It says find the 6 trig functions for each given real number t. T being then that arc length that our point is traveling around the unit circle. Okay. So if we simply got our unit circle, actually let me do this. T equals pi. Let's just come over to this. All right, so they're asking you to find the 6 trig functions for t equals pi over 3. Okay, so that means to me that we're looking at this arc here where pi over 3 would maybe be about right there. Okay, pi divided by 3 is about 1 something, isn't it? Okay, 1.07 maybe or something like that. 4. What is it? I'm interested now. Pi divided by 3, 1.04. Okay, so we're pretty close here. We should, with t equaling pi over 3, we should know what the ordered pair is for that point based off our unit circle. And if we couldn't remember it, if we can't get it off of recollection, we should be able to do this. And pi over 3 is 60 degrees, right? So this would be 1. This would be root 3 over 2. And that's 1/2, right? So this ordered pair, to go from 0, 0 to p, I would travel x distance of 1/2 and a y distance of root 3 over 2, right? Is that okay with everybody? So that's maybe one way if you struggle to figure out what your ordered pairs are. Implant a special right triangle there with a radius of 1 and go through your template. But now they're going to ask, well, what is the sine of pi over 3? What is the cosine? And what is the tangent? Okay. We evaluate those, and then we'll come back and we'll do the reciprocal ones as well. But what is the sine of pi over 3 now? Yeah, it's that one right there. Sine is the y value, so it's root 3 over 2. What's the cosine of pi over 3? 1/2. And the tangent then is sine divided by cosine, right? And that will evaluate. College algebra tells us that will go down to radical 3. Is that something we can do? Okay. Now I want to do, what's the reciprocal of sine? Cosecant. So cosecant of pi over 3, cosecant of pi over 3 is going to be 1 over y, or now that I've got this, it's just a reciprocal of this, so it would be 2 over root 3, which is going to rationalize to give you that. 2 radical 3 over 3. Cosine of pi over 3, its reciprocal is secant. So what's the reciprocal of 1/2? Okay. And now cotangent pi over 3 is the reciprocal of radical 3, which ends up being, if we rationalize it, radical 3 over 3. And those are things, guys, I know it took some time, but those are things that eventually, because of how much we're going to use the unit circle, those are going to be, at the top of your, just be able to do that as fast as you can do 2 times 3. Okay? You'll be able to recall those things very, very quickly. Now there is issue when they ask us what about dealing with something like that, where our t value now is pi over 2. So I'm going to try to figure out the sine of pi over 2, the cosine of pi over 2, the tangent of pi over 2. Once we find those, we'll go back and do the reciprocals. All right, so if I've got sine of pi, what is this ordered pair here, though? 0, 1. So what is the sine? 1. What is the cosine? 0. Now when I do tangent, okay, remember this was sine is your y value, right? Cosine is your x value. Tangent, okay, is y over x, or if you want to think about it as sine over cosine, right? Well, what's 1 divided by 0? Undefined. Okay, which we've talked about that briefly, but I think it becomes very important when we start talking here in a moment about the reciprocals. If I deal with, what's the reciprocal of sine? Okay. So the reciprocal of sine is cosecant, but the cosecant of pi over 2 would be the reciprocal of this one right here, right? Reciprocal 1. So somebody did say 1. Okay. Now I'm going to look at secant, right? Secant of pi over 2. Now think about this. It's the reciprocal of this number right here, right? It's the reciprocal of 0. Well, can I put any denominator here that I want to and still get 0? 0 divided by anything is 0. So I'm just going to put the number sign there, okay? So there's a number there. I don't care what it is, though. For us, it would have been 1, right? Would have been adjacent divided by hypotenuse. But if I take the reciprocal of 0 divided by 1, my reciprocal is now 1 divided by 0. And what's the problem with that? It's undefined. Okay? So undefined. Okay? You can also remind yourself, well, cosine was x, so the reciprocal of that is 1 over x. And if I look at my x value here is 0, 1 divided by 0 is then undefined. Okay? What about cotangent? Cotangent of pi over 2. Yeah, it's the reciprocal of that. So that is okay to do, all right? 0 over 1 is 0. Okay. Now this is why I like Desmos, the one situation that I like it. It's because it does a good job of being able to say, okay, sine of pi over 2, 1, cosine of pi over 2, 0, tangent of pi over 2, undefined. And now when I want to get to my reciprocals, cosecant of pi over 2, 1, secant of pi over 2, undefined, cotangent pi over 2 is our 0. Okay? But those are things, guys, that we're going to want to be able to do without the use of a calculator. I do think maybe initially it's a good idea to use the calculator to convince yourself of your answers, to verify them. But it's going to be something that we really work hard not to use our calculator with. Because the sine and cosine are just x and y values, right? On a unit circle. Because of that, and I want to go to, I've got a couple of these things open. Let's go to this one. All right, now it should be in radians, and I haven't adjusted this thing yet, so it'll work with radians or show radians instead of degrees. But look at, when I move this slider, you see how it's tracing out the red arc, right? Which is our t value, correct? That's our input. And notice that everywhere on that unit circle, there should be x and y values for that point down here, that point M. Okay? So, and as many times as I want, you see right now that my angle's at 500. And I can keep going, and my angle can be anything it wants to be, right? Okay. Now it's in degrees. If it were in radians, it'd be still a valid argument. That's what we want to do, is view it in radians. But that arc length would then be maybe, we're probably up on the 4 revolutions now. Pretty big arc length, but it is still able to evaluate for sine and cosine and tangent. Does that make sense, everybody? Sine and cosine. Okay. Because no matter what, we're getting ordered pairs back, which are x and y's. So that argument is allowing us to say that the sine and cosine, the domain, your input values, are anything that you want them to be. Okay? I was just showing the positive version, but we could have moved clockwise and got the negative versions as well. So that's why all real numbers, not just positive ones. Now, tangent and the secant, those are issues, because remember the tangent is equal to y over x, and the secant is a reciprocal of cosine, so that's 1 over x. X cannot be 0, right? X equaling 0 happens at pi over 2 and 3 pi over 2 initially inside the unit circle, right? Now, if I want to keep going around the unit circle multiple times, I can say pi over 2 plus n pi, should be a semicolon, where n is an element of your integers. Okay? So if n is 1, I'd have pi over 2 plus pi, right? Well, that's 3 pi over 2. Okay? If n is 2, that's pi over 2 plus 2 pi. So it gives me the 5 pi over 2. So it gets me back to pi over 2, and then to 3 pi over 2, and then back to pi over 2, and then 3 pi over 2. Okay, it lets me jump back and forth on top and bottom of the circle. Does that make sense? Okay. And those, obviously, you can't do division with 0, so that's why we've got domain issues there. The cotangent and cosecant, okay, cotangent is x over y. Cosecant is 1 over y. So y cannot be 0, okay? And that happens at pi and 2 pi, or if you want to just call it 0 and pi. A lot of times we call it 0 and pi instead of 2 pi. 0 and pi. And then what we can do, okay, so if I go from 0, I add to it pi to get 2 pi, and then I add another pi to it to get to 2 pi, and I can add pi again to get to that, to get 3 pi, right? Would 3 pi be the same thing as 0? Or coterminal with 0? Then add pi to get 4 pi, which would be the same thing. 3 pi should be the same thing as pi. 3 pi is the same thing as pi. Add pi to that, I get 4 pi, which is the same thing as 0. Add pi to 4 pi and get 5 pi, which would be the same thing as that. So you see you're going back and forth between that point right there and that point right there, but by just adding pi, right? So my starting point is pi, and add to it, pi n. So really what you can do is just say pi times n is going to be your little short, concise formula that's going to allow you to find then all the places where the cosecant and cotangent are undefined. Okay? And that's going to be very useful for us, because we're going to, in the next couple of days, start graphing these things on the x and y axes as curves. And we can know where these functions are undefined, because graphically, think back to college algebra, when something was undefined graphically, say we had division by 0, okay? What did that provide us in the xy axis for our graphs? We did a lot with rational functions. Some of them were vertical, some of them were horizontal. When you divide by 0, you always get a vertical asymptote, don't you? Okay. So we're going to get some asymptotes here in a little bit, okay, within the next few days. Does anybody have questions on that? Anybody confused, concerned, worried, lost? Again, if you are, do not hesitate to come find me. All right, this stuff is critical for everything that we're going to go and do after this. Okay, and the difficulty is going to increase kind of rapidly and drastically. Okay, so if you're fighting to learn this stuff at the same time that difficulty increases, and you're trying to learn the new stuff, you're going to have a hard time of it. Okay, this is simply just telling us that all students take calculus, right? We already knew that mnemonic device to tell us where all of our functions were either positive or negative. If you look at some people don't like using all students take calculus. Like some textbooks will do this. Every point in here is a positive in the first quadrant. Everyone over here is negative positive in the second. Everyone here is negative, and then this would be positive negative, right? Okay, and we know that the x value, I'm just going to write C being the x value, that's cosine, right? X and cosine match up, and S is sine. So now, do you know where the cosine and sine are positive and negative throughout the entire coordinate plane, the entire unit circle? And if I know where the cosine and sine are positive and negative, because I know where x and y's are positive and negative, I should be able to divide sine and cosine. I should be able to divide a positive and a positive and get a positive, right? That tells me in the first quadrant, tangent's positive. I should, in the second quadrant, be able to divide a positive with a negative and get a negative. So it tells me tangent in the second quadrant is negative, right? Does that kind of make sense, everybody? And you can do that in all the quadrants. So in the third quadrant, tangent should be positive because it's a negative divided by a negative, right? You can do the same thing with reciprocals. Okay? Wherever the cosine is positive, its reciprocal is as well. Wherever it's negative, its reciprocal is negative. Is that all right? Okay, so maybe a different way of viewing the phrase, all students take calculus. All right, so the culmination of this. What are we doing here? Why are we doing this? Okay? And there's a couple ways of viewing these things, guys. So I'm going to, I want to show you the way that I feel comfortable doing these problems, and show you maybe little intricacies that you can adjust to make it understandable to you and allow you to work maybe at your own pace. But when they ask me to evaluate cosine of 2 pi over 3, what that means is do not grab your calculator, because your calculator, no matter how good it is most likely not going to spit back to you. Well, it's real nice. This one's negative 1/2. But if it was a radical, it was an irrational number, it's not going to spit back to you the exact value. It's going to be round decimal. Okay, so that's a problem for us. We want the exact ones. Okay, so this is kind of the approach that I think is useful. Okay, now whether you want to think about that as your t value or theta, we know they're the same, right? Okay, so I'm going to draw out an arc that looks like 2 pi over 3. Okay, and eventually, guys, you will know that 2 pi over 3 resides right there. Okay, because, and hopefully maybe you already do, because pi over 3 should be there, right? And what's pi over 3 plus another pi over 3? 2 pi over 3, right? So really I'm taking that arc right there, and I'm using arc addition, and I'm going to repeat it right there, and then that point lands there. Does that make sense? Okay. So that arc there, that point would be 2 pi over 3. Okay, whether you, like I said, if you call that t or if you call that your theta, theta would be this angle here. Okay. They want cosine. Well, if we're on the unit circle, that thing has an ordered pair, right? Okay. Now, my argument is that maybe you haven't memorized that ordered pair from the second quadrant. So let's do this. Let's find that arc, which we call T bar, don't we? Okay. If the blue one's 2 pi over 3, what's the red one? Pi over 3. Now, my argument is that somewhere you should have committed to memory that pi over 3 has the ordered pair 1/2 root 3 over 2. Okay? So what that tells me then, remember the reference angle, or the reference distance, is telling you that this point here of 2 pi over 3 has the exact same coordinates that the reference value have. So the reference value has that set of coordinates right there. So this blue point should have the exact same ordered pair. Okay? But this blue point is in what quadrant? Second quadrant. So the x value should be negative. So if I do it that way, guys, all I've got to do now is that now I know I've created the ordered pair for cosine, for 2 pi over 3, and the cosine then is which one of those ordered pairs, which coordinate? The x. So that's why I get negative 1/2. Okay. If you're a person that doesn't want to take this, if you really, and this is usually the advanced people that maybe were working with this for a while and really understand and grasp this. We know that the cosine of 2 pi over 3 is going to have the same coordinates as the cosine of pi over 3. Does that make sense? So what's the cosine of pi over 3? It'd be that 1/2, right? So cosine of 2 pi over 3, it's going to have the same 1/2 distance. Okay? But 2 pi over 3 is what quadrant? Second quadrant, and all students take calculus tells us in the second quadrant, cosine is not positive. So we can change to negative that way. And that way, I never had to write down the ordered pair of 2 pi over 3. I just looked at the ordered pair of pi over 3, right? Okay? Again, it's all an efficiency thing. It's all how fast you want to be able to go through these and use maybe the different relations. I think it's good to understand all the maybe different ways you can do these problems and realize and work with these problems. And that's what happens with a lot of these identities that I'm going to provide you here shortly, is that they allow some factor of efficiency to take over. So let's do tangent of negative pi over 3. Tangent of negative pi over 3. Negative tells me what? I'm going to go that direction. Okay, so that might be t is negative pi over 3. What we talked about the last couple days is if I want to find this angle or find this ordered pair, call it point P, I need to know what the arc length to get back to the x-axis would be, right? Well, what would t bar be in this case? Yeah, it'd be pi over 3. I just retraced what I traced out the first time, right? Okay. So t bar is pi over 3. So then if I know the ordered pair for pi over 3, which the ordered pair for pi over 3, maybe you need to draw a picture. Some of you might not. But pi over 3 would be about right there. The ordered pair is 1/2 root 3 over 2, right? It's the one we just did. So this ordered pair is going to be the same thing, right? It's going to be 1/2 root 3 over 2. And now what is the one thing, the slight difference here? Yeah, that's negative, right? Okay, the y value is negative. Think about this, guys. If I have negative pi over 3 as that point down there in the fourth quadrant, should be here, right? That arc would be negative pi over 3. Or is that point there and that point there, are they symmetric about the x-axis? Okay, so they're just reflections, right? So the x distance, they both have an x distance of 1/2, right? This one has a y distance of radical 3 over 2, and it's up. This one has a y distance of radical 3 over 2, but it's down, so that's why it's got to be negative. Is that all right with everyone? So now when I want to find the tangent, all that work was to find the ordered pair. The tangent is the y value divided by the x value, right? Okay, sine over cosine. So that's going to evaluate to negative root 3. When we deal with one like sine of 19 pi over 4, okay, 19 pi over 4 is much larger than 1 revolution, right? So we're beyond 1 rotation average. So what I'm going to do is I'm going to take sine of 19 pi over 4, and I know that's going to be equivalent to the sine of 19 pi over 4 minus 8 pi over 4. Now it'll give me 11 pi over 4, right? But 11 is still bigger than 2 pi. I'm going to subtract another one. So that will equate to what? Sine of 3 pi over 4? Is that okay with everybody? Now that exists inside 1 revolution, correct? 3 pi over 4 would be maybe right there. What is the t value? Not t value, but the t bar value, the reference value for 3 pi over 4. How far would that red arc be right there? Pi over 4. And the hopes are then that you know that pi over 4 is that ordered pair. Okay? So, sine of 3 pi over 4 is going to be the exact same thing as sine of pi over 4, which is root 2 over 2, right? It's that y value. But now the y value in the second quadrant, what kind of number is that? Positive, right? And that's what we've got. And what's nice about that, guys, we just found radical 2 over 2, which is exactly what, if I type into my calculator, sine of 19 pi divided by 4, it gives me radical 2 over radical 2 over 2.707. Okay. Is that something we can kind of work with? There's some questions in your homework dealing with that. Tomorrow we will start. I'm going to skip these. That's just using your calculator, guys. That's something you guys can do on your own. Tomorrow we'll start with these even-odd properties. Okay, and that's going to help us get into section 6.3 eventually.